grassed waterways for like mitigation of concentrated flow paths
Yeah.
in an agricultural system.
Awesome.
So it's a new project. I guess that's also important. So this fall I was doing a lot of like the preliminary data, like
Yeah.
figuring out where we're going to be working. So
Awesome.
we have like a few places on the university farms, different like gullies, places of erosion in like the university farms, agronomic fields, you know.
Hmm. And everywhere else, yeah.
Yeah, right.
Unfortunately.
Yeah. And most of the classes I'm taking are geared more soil science for the most part.
Okay.
So I feel like my end goal would be to be either like a soil conservationist or a soil scientist.
Awesome.
I do have a pretty strong ag background. I grew up on a farm in central Illinois, so
Cool.
my dad still farms up there. So just looking more, like I'm really passionate about like the conservation aspect there.
Was it like corn and soy
Yeah.
operation? Right.
Corn and
Big farm, small
soybeans.
farm?
I'd say more like mid-level, but
Okay.
still pretty small. Like
It's not like corn royalty,
no,
but you know,
up there,
pretty
I
substantial.
mean, people have like thousands of acres. They have like 4 combines. We're definitely more like family farm. It's mostly my dad, my sister, and her husband that do everything.
Okay.
Yeah, and then like growing up, I had cattle. So yeah, farm life.
All right.
But I think like the smaller farms, you know, are really dwindling, and I feel like
Especially right now.
right now it's tough for them. So just offering these like conservation practices, because like what got me into it was my dad. He's always been very like, I want you guys to be able to farm here in the future. You know, it's really important that he's
Awesome.
like
Okay.
preserving it economically and conservation to pass it down to his kids. And I feel like that's what a lot of family farmers aim to do ultimately. Although like obviously profit is the first thing they have to worry about. So just making these like conservation practices more readily available. Yeah. So there's like an economic component of my research where we're looking at how they are actually affecting yield. You know, like if you
Mhm.
plant through this
Yeah.
gully and
Right.
you lose all of the seeds, you're losing money. Would you be more economically, you know, would it be more economical not to plant through it, to put in a grassed waterway, stuff
Yeah.
like that?
And you know, how much does it cost to put in the extra waterway? Like it's more work and time and
Right.
less space for growing your cash crop, but
Exactly.
yeah, cost benefit.
Yeah.
Management and optimization.
Exactly.
Sounds like science could help.
Right. Yeah.
No, that's really good to hear. I'm glad that your dad has a long-term conservation view on it. You know, and I think a lot of the, especially a lot of the smaller farmers, more recently, have been pushing hard in that direction because you know, a century ago, the soil loss and erosion across Illinois was catastrophic during the Dust Bowl.
Yeah. Absolutely.
That's why we even have the Shawnee National Forest in the first place. They used to be all farms, right?
Right. Yeah.
So, anyway, all right, let's run through the syllabus, and we'll go through it with a mind towards figuring out what's the right timing for you, Abby, this year or this fall.
Okay.
So this is originally designed as kind of a grad school, kind of like a 101 class for specifically science-oriented grad programs.
Sure.
So it's fundamental principles and practices, and it's everything from what's like the history of ontology, like how do we know what we can know? Super philosophical question, like back to the ancient Greeks and stuff like that. Right down to what are the top 3 things that I need to be doing today, literally today, top of my checklist, to move the ball a little bit further forward while also staying sane. So it's big scale, but it's also very close in scale as well. You'll be prepared to begin or continue your program of graduate research productively. Course topics will help you move from proposal to publication effectively. So the primary deliverable of the class is basically a thesis proposal, a thesis proposal draft. It's never like done, right?
Right.
It's always a living document, but in talking with grad students over the last couple of decades, that tends to be one of the biggest stressors. And so the sort of skeleton of the class is starting with your idea, turning that into research questions, and then chunking down the whole process of writing a proposal, which a lot of students, they've never written a document that big and that technical, so it can feel pretty intimidating and like cost more energy than it should or than it has to put it together. So that's the main thing, and at no point is there ever a sit down and write your whole proposal kind of assignment. It's like, write these 3 sentences. So it's chunked way, way, way down, and each day's work is pretty atomized down. So you'll have an understanding of the philosophy and ethics upon which your research is constructed. We'll talk about like pretty horrible Nazi experiments on people and how that relates to science and why we have to jump through some of the hoops that we do for good reasons these days. You're going to have a ready-to-go, turnkey ready research proposal, fully written and good to go with your advisor and graduate committee. We'll also walk you through a bunch of probably do this and don't do that kinds of guidelines for how to pick people and put them on your committee and what to watch out for with that. There's a profoundly human element to science, as much as science is dispassionate and, purely logical and all of that stuff. Humans are not always dispassionate, not always super logical, so practical tips on stuff like that as well. A super detailed semester by semester checklist for your whole time. You're already a couple of pages into that, and that helps to tame the chaos a little bit, just to see when and where to expect everything along the way, so that at no point do you feel like I got to do everything. We go through lab notebooks, how to set that up, how to run that each day, a log book or whatever. And then this is a really, really long syllabus, 14 pages long. It's just a huge outline list of basically many dozens of different kinds of research methods. And just talking through like, what does this method get you in terms of data and data quality and data extent or depth versus the cost and time and your safety in the field and monetary cost, human capital, or having like capital equipment, super expensive sensors and stuff like that. Like with Schoonover, there's this big cost-benefit analysis on doing ground-based total station LiDAR precise measurements of erosion in gullies versus drone overflights with a LiDAR head. The head itself might be $250,000 versus like strap a nice GoPro on there and do structure for motion, 3D reconstruction. Like all of those give you slightly different things, but you're just trying to get at like, how's the soil surface changing? What's the sediment transport and stuff like that. So we go through a bunch of those. This class doesn't have the scope of the time to like teach you how to do all of those, but it's to help you have an awareness, as especially sort of a middle of progress grad student, awareness of all of the other things that you could be doing and why you're not doing those and why you are doing what you and your advisor are working on together very closely and working real hard on it, and then there's that science communication piece as well. For us, it's a couple of weeks of discussion and like presenting your thesis proposal or your draft proposal at the end of the semester in like a 15-minute format. That's perfect for practicing for conferences because you want to get your word out there even before you finish. And also presenting your proposal to your committees. Some committees really want you to be, stand and deliver and talk us through this thing page by page or point by point. And other committees are like, I read it, you don't have to waste my time, So we'll equip you with a bunch of best practices for science communication and stuff like that. Being a grad student is not a fiscally glamorous thing for a couple years at a time, so all of our textbooks are totally optional. And Abby, please pick and choose and suggest other ones that you find that might help others down the line to add to this list. So yeah, the next page has a little bit of a kind of a dendrogram or a flow chart to help sort which kinds of books to get. For you, it's geospatial and physical. So Ian Voss's Design and Analysis of Experiments. This is a classic, like quantitative, statistical. I'm taking clear numeric measurements. How do I work that up? How do I set up the research to make sure that that's like valid and effective and safe and all that stuff? It sounds like you're kind of geospatial, like you're going to be using a lot of LiDAR, point cloud analysis stuff, and that sort of thing. Okay, awesome.
GIS type of stuff.
Yeah.
Yeah, definitely.
GIS can do everything now.
It's crazy.
Like, it's wild.
Yeah, it is.
And that can be a little bit overwhelming too. So these particular books I found are excellent for helping to kind of order that unbounded chaos into sort of all right, A versus B, let me go B this time. For this project, for these reasons, that kind of thing. And then for human research, you don't have to worry about those because that's not really your thing right now. This class is trying to be as hands-on as possible without being able to get into all of the students' research groups and labs and stuff like that. So, bring your laptop. We'll go through some guidelines and requirements for a research notebook or logbook or journal, whatever that looks like for you. And, it's going to be pretty informal, so come ready to chat.
Okay.
Don't come if you're ever feeling really sick, right? You're not going to impress me by getting us both sick.
Right.
And also my wife is a little bit immune compromised for airborne stuff, so I got to be careful about that. This class is highly cognizant of the idea that spring semester, pretty soon now, a lot of grad students are going to be like out in the field collecting data back and forth, trying to nail down classes as well.
Yeah.
So if you ever have to drive up to, back up north towards home or whatever, to hit any of your research sites, that's totally fine. I am not going to take attendance for this class. And especially if you have something like a conference to prepare for, let me know as far as you can in advance, and we'll move around the timing and the assignments a little bit so that the work you're doing to prep for that counts for this class as well, because that's what this is about, getting you ready for all this stuff. So that's probably the thing. Let's see, 1250, yes. I don't think anybody has ever gotten less than an A in this class, so
Cool.
grad school grades are different. It's different. The big thing, again, is your research proposal. It's almost half your grade. Again, that's broken out into a bunch of different smaller milestones. 20% to bring you up to 60 cumulatively is that 10, 12, 15, 18-minute presentation of your research. So it's the same content but reformatted totally for PowerPoint or Keynote or whatever you want to use, or any of those vector ones where you can zoom in and out. I forget. There's a whole bunch of PowerPoint alternatives now. And then the remaining 40% are smaller things. So your research logbook or journal, a couple of on-campus seminars. There's a form at the end of this syllabus, so you can find that in there on your download. To go to somebody else's graduate seminar outside of forestry, and there was a TEDx series of events here on campus a number of years ago. Just go to anything where somebody's communicating science, either at a highly technical level or at more like a general audience level or something in between, like a TED Talk. And regardless of the content of it, can I calibrate your sense of, okay, this person presented XYZ in this way. I don't think that would work for my particular style, but I really like how they did this other thing, like this chart or this figure, and how they walked us through that and really picked apart something complex and made it just crystal clear. Those little critiques are super helpful for speeding you up quickly on becoming a more capable and comfortable, confident presenter. Not that you're not already, I'm just saying. And then our other big thing is the annotated bibliography. So this isn't part of your thesis or dissertation template. It's a separate document but it's one that, especially if you go into like extension and stuff like that, this thing is just going to grow and grow and grow. It's a simple text file. There's no formatting or anything. You don't have to use any particular program. I use a plain text file, so it doesn't matter what computer I'm using to write it. Just anytime you come across a publication, a journal article, or whatever, what's the citation info, and like what's the one or two most important points or sentences out of the whole thing. You can copy and paste them if you want. You don't even have to do that much writing. But this thing can be hundreds of pages long eventually. So we'll just get that started.
That's definitely helpful.
Yeah, and have you started writing your proposal yet?
Minuscule.
Yeah. Okay, cool.
Yeah.
Great. That's perfect timing for this class then.
Yeah.
So, as you get into the habit of just adding one or two things, getting it out of your brain so you don't have the sort of subconscious stress of trying to remember that stuff, but you're not ready to throw it into your proposal yet because that's not written yet.
Yeah.
That's the right parking lot for it, and it becomes really sort of almost reflexive to pop that thing open. I keep a copy of it on my phone's channel, so if I'm just
Right.
reading something over coffee in the office or whatever, everything gets dumped in there, and it's so easy and fast to populate like a literature review or a discussion section. This takes so much of the stress out of it. So.
Yeah. I don't know why I didn't think of that. Like I've written those before, but
Oh yeah, no,
right now I just
no
have all
worries.
these articles sitting in a folder, and then I'm like, which is which? So yeah.
Yeah, no worries. And we'll talk about some ways to do like, you can use EndNote or BibTeX, or there's Zotero. There's a billion different like citation managers and stuff like that. Sometimes those can be fragile, like break easily, or they can be expensive. EndNote's pretty expensive. So this is kind of a future-proof way to always have access to your hard work and not have anything sort of fading out of memory. So yeah, we don't have a midterm or final exam because those are the wrong kinds of assessment tools. We'll talk a lot about assessment and data collection tools in this class. And final exam is not a good use of your time, which is very precious as a grad student. This has never been an issue in graduate school for me in over 20 years, so I'm not too worried about it. The main thing lately is just be clear about how you are choosing to use or not use something like ChatGPT. I view it like a tool, like spell check or whatever. But don't trust it because it will confidently hallucinate. The current false positive rate on ChatGPT Pro is something like 30% incorrect, which has like a thesis can be 0% incorrect, but it sounds really good. It talks a really good game as it is lying to you or hallucinating to you. But if you're just not sure how to word something and you're spending a lot of brain calories on like, how do I say it like this, like that, it can help you get unstuck and then, back to your own writing in your own head. But if you do have any output like that, just cite it as, ChatGPT or Gemini or Grok or whatever you want to use output, Copilot.
Is there a specific AI that's more academic, or are they all?
That's a great question. There are a few new products essentially based on ChatGPT or Gemini, so running that, not operating system, but that framework, that are trained more specifically and more heavily weighted towards just journal articles and stuff like that. The problem is the hallucination. It can help you. It's a really, really powerful fuzzy search. Like if you don't know exactly the right key term, it can help you get there instantly. But it will just like make up links to things that just don't exist because it's just trying to predict what word comes next, not necessarily copy pasting fact into the chat log.
Right.
So yeah, it's a useful tool. Just don't trust it.
Yeah.
It's a fast tool. Just don't trust it.
Absolutely.
So let's see here. The class topics: research proposal. We'll pull up the template here in a bit. talk about your lab notebook, best practices, and we'll pull up that project checklist. That's today. On Thursday, we'd start talking through kind of like the fundamental knowledge underpinnings of science. Why do we use science? Why do we use science instead of other approaches? And if you've never had a chance to think about, like, why do scientists do stuff the way they do, that's what the next couple weeks are kind of about. So Nazi stuff and CIA stuff in terms of ethics of research, and then we bring it back from gory stories to very practical hints and encouragement to, okay, my advisor asked me to do something that I'm not comfortable with for whatever reason. What do I do now? Because your advisor determines a lot of your professional life while you're a grad student, but you're not totally washed up if something goes sideways with your committee, or if you see somebody else's advisor putting some improper pressure to do something that's unethical in research. What do you do? Where do you go? Who do you talk to? There's a whole framework for that. Unfortunately, it is a necessary framework, but there's always a couple of weirdos out there. All right, we'll get more into the annotated bibliography in next week, and kind of just set that up as every time we have class together. Tell me about one paper you read or something that got into the annotated bib from there. And then we get into the design of research. So if whatever you're studying is very broadly or generically called a phenomenon, how do we look at it? How do we start to measure it? Stuff like that. How do we account for time? So soil transport along concentrated flow paths is a dynamic and changing process. So do you take a single snapshot, or do you have to remeasure it once a day? Or do you remeasure it once every 30 years? Or how do you deal with time? Time is among the most important variables in all research. So we'll spend a whole day talking about that, for a whole 50 minutes. And along with that, especially in time with your annotated bibliography getting kind of started up that class session, we'll talk about techniques in literature searching, forward searching, back searching, appropriate ways to get an article, or effective ways to get an article if it's locked behind some paywall and you're like, I'm a grad student, what am I going to do about that?
Right.
There's lots of ways that you can get your hands, even legally, on research, even by just emailing the study authors and saying, hey, I'm a grad student, can I just get a copy or a draft of a galley proof of this? I can't find it any other way, and it's the perfect study for what I'm working on. Please help. And then more in research design, this is what am I really trying to measure? Correlation versus causality. If slope is an important factor, or seems like it matters a lot for erosion, how do we know that it matters, not just varies with it? Units of analysis. Am I analyzing individual sand grains? Am I analyzing soil at the PED level, at the field level, at the georegion level? What kind of spatial and other kinds of scales are we boiling down the real phenomenon down into numbers and variables, and so forth? And then operationalization, how do I take these goofy, sort of quasi-philosophical but practical things and turn them into what I am actually going to put a number on out in the field? And then how am I going to sample it? Does it need to be representative or non-representative, or probabilistic or not, etc. Sampling frame, designs, site selection. So this stuff at the master's level is usually kind of done for you, right? You know, the research team has typically a year or two before they bring you on to start working on field work and field techniques and stuff like that. They got to go out and, you know, chase the funding down to do it.
Right.
So some of this stuff is sort of done in their proposal,
Yeah.
out of which your proposal, you know, covers some piece of it. So we'll talk about it at the sort of project proposal level and then at the thesis proposal level as well. And stuff like considerations for site selection, like if you end up working for NRCS or somebody like that, like a lot of the factors that they have to keep in mind have a lot to do with site selection. So yeah, and then this class, just like with individual research groups field techniques, we don't have time to like teach you all of the stats.
Right.
That would be too much. But I'm at least gonna help sort of clarify at kind of a schematic level, like what is your advisor talking about when he says or she says interaction effects? What's a double-blinded study look like, and what does it mean for me practically if I got to do this stuff? And just help kind of set up the conceptual landscape for how to pick what you're going to write in your specific method section. So you got to mention all of these things to some level. So sort of map that out for you and help get that done. Qualitative stuff, we're probably just not going to talk about this for you.
Yeah.
Um,
It's not super relevant.
Yeah, it might not be the most useful thing for you. Simulation modeling, on the other hand, could be super useful, and you might end up building a model or running some previously established models like RUSLI, Revised Universal Soil Loss. Yeah. And one of the most important things in this whole shebang is the idea of delimitation. So you don't have to measure the entire world, you don't have to analyze the entire world and thereby never finish because it's an infinite amount of stuff. What are some healthy boundaries you can put around the scope of your project? That's called delimitation. So a lot of grad students often stress about the little section in methods or results, the limitations of this study. And it always feels bad to write that.
Mm-hmm.
But a good delimitation section is very healthy and sane to write and makes that limitation section, things that we couldn't handle or we handled poorly, if we exclude those things at the beginning on purpose, then that's very reassuring to your readers, like, oh, well, Abby really knows what she's talking about here. Like, she's not even touching this problematic part of it. Great, awesome. We can move right on at full speed with what she did work on. Quality control, smaller scale or earlier scale studies, like pilot studies, Delphi studies, pre-experiments, quasi-experiments, stuff like that. That can be much more successful on the tight timeline than a lot of grad students have. And having a few ideas for a pilot study in your back pocket in case for some reason like a tornado goes through and knocks out 3 of your research sites, is there something else you could ask at a smaller scale that still teaches you how to be a good soil scientist, right? So that you don't have to like spend an extra 2 years in grad school like not making any money, and stuff like that. Let's see, field logistics, safety, backups and emergencies, and then we start to give you guys and gals some early hints on what are you going to have to do to process your data to get it ready to analyze, what are you going to have to do during analyses, and all that stuff. So again, at the conceptual level, not the procedural sit down with SAS or SPSS and crunch numbers yet, but at least you'll be able to jump into your stats classes if you haven't already taken those.
Currently taking
Okay, yeah,
one.
cool. All right, so if you want, we can move this stuff up earlier into the discussion and, you know, help cover this stuff kind of simultaneously with that class, if that's helpful.
I'm taking inferential statistics because I
Okay, awesome.
biostats, which they usually take, falls during Trinity in the fall.
Ooh,
So they might
yeah.
change it, I don't know, but they have a new professor or something,
Okay.
But I was like, I think I just need to take a stats class. So that's over in Quan. I think it'll work out.
Yeah.
Stats
If
and
it's, is it with Dr. Jennifer Cloran?
No, it's with Kowalchuk.
Kowalchuk. Okay.
The other one, I know she does the multiple regression
Mhm.
course, which I'm planning on taking next spring.
If you take that with her, Dr. Karan, you will understand it.
Okay.
She is the greatest of all time.
I've heard that as well.
Yeah, she's not easy, but
Right.
she's extremely, extremely capable and functional to help explain stuff. She helped my wife with some sort of obscure statistical analyses on her PhD studies.
Gotcha. Yeah,
And
I've heard she's great.
yeah,
so
she's legit. I don't know much about Kowalchuk,
I think that's what it said.
but
She's been.
okay.
She said she's been here for a while, but she's like, I still hold on to some of the. She like did all her schooling there, so she's like, I say Zed.
Oh,
when
okay.
you're thinking Z's
Yeah.
before. She's like, yeah. Just know I'm referring to the last letter in the alphabet.
When I was at Virginia Tech studying for my PhD, one of the classes that my whole cohort had to take was multiple regression, and it was taught by a guy from Southeast Asia, where their phonetic system doesn't have the L sound,
Oh, yeah.
and they transmute all of that to an R sound, and we could not, for the life of us, figure out what he was putting on the board versus what was in the textbook, and it was like, oh, half alpha is actually half alpha, which is like a key statistic, and like it's like I get it. Yeah. So yeah, hopefully the accent isn't too thick.
Right.
And the class was fine once we figured that out, but
Right.
it was just really disorienting. It's like he's saying something, but I don't see it anywhere.
Yeah. That happens.
So yeah, there's a lot of stuff that statistics can do for you. But we'll talk about what statistics kind of strip out of the data in certain kinds of studies, and what statistics can hide if done wrong, hide in a bad way. So yeah, geospatial, mixed methods, communicating research, right, is a couple of class sessions, and technical writing, like journal article, draft writing, and stuff like that, is an acquired taste and skill. It's weird, but for very specific reasons. It's passive voice, and everything has to be completely unambiguous, and it takes 10 words to say 3 words worth of concept, but it's functionally precise across multiple cultures and many different languages that have to use your work and stuff like that. So we'll talk about those things and help demystify the much softer process, or softer feeling process, or less defined process of how to write well. Again, not a whole semester worth of that, but a couple of class sessions targeting that specifically. And then towards the end, it's pretty much just proposal seminars. Normally we have several more people taking the class, so we have several class sessions built out for that. But after spring break, the tempo of the class changes because, out in the field more, and more doing things and breaking down the steps to get to your proposal and presentation or seminar by the end of the semester, and stuff like that. So,
Appreciate that.
and then here's the seminar form. Just a couple of points. What did they do well? What would you improve if you did it? And so forth. All right.
Cool.
So that's the main stuff. What do you think? If you need to take a couple of days to think about it, that's fine too. But
yeah,
first
I can
thoughts?
definitely do that. My initial thoughts are, I definitely see why you want this to be a fall course. If it's like people traditionally coming in the fall,
Yeah.
it'd be really helpful. My only concern is that if I didn't take it this spring, the fall would almost be too late, to
Maybe
start
so,
thinking
yeah.
about this type of stuff, especially if I'm trying to do, 2 years. But
Yeah, that means you get one summer in the middle
right.
to do all your field work.
Yeah, right.
So I have had folks take this as late as their 4th semester and still get some value out of it because they're writing as fast as they can at that point.
Uh-huh.
But yeah, this is really designed to be kind of front loaded as much as possible. So if you want to do it this semester, let's do it.
Yeah, I mean, I'll definitely think about it, and then like the only reason I bring up that class that Brevik's teaching is it's like, well, maybe that'd help me kind of get started this semester, and then come it back in the fall. Maybe, I mean, do you anticipate there'd probably be other students in the fall?
I do. This class is anywhere from typically like 3 to 10 students at a time.
Yeah.
And I never know. It's
Right.
so random when people come in and
I know.
research projects open up or wind down or whatever.
I was surprised.
Yeah.
I was the only one. But, because I mean, there's probably definitely some benefits from having other students in here at the same time. You said seeing their proposal presentations and just talking over different research.
Sure.
So, yeah, I'll talk to Brevik and maybe see like if some of his classes could help me get started rather than putting it all off.
Okay.
That's my only concern, is that like this would definitely help me.
Yeah, no worries. And either way, I'd love to make sure that you get the proposal template.
Okay.
It's like, the template's like 30 pages long,
Okay.
but
Yeah.
it's got a whole bunch of little tips in there. You just delete those and write your stuff.
Yeah, that'd be great.
Either way,
I think I
so.
forgot the email with the, there it is, yeah, okay.
All right, cool.
I'll think about it. I mean, I definitely would, either way, how it could be.
Okay.
beneficial.
Cool. I'll, while you're thinking about it and chasing Brevik down, I like Eric Brevik. He seems like a pretty chill dude.
He is, I've had a lot of classes with him.
Okay.
Going more soils
Yeah, mhm.
based, so.
Awesome. I'll put a link in the front page of the course
Okay.
in the announcement section here, directly to any of those template files, so you have them regardless of what you choose.
Okay.
So, yeah.
Like, I mean, if you're not offended if I take it in the fall or whatever, I might do that. I'll see. So,
Totally
I'll
up to
let
you.
know.
Yeah,
I'll
no
come
strings
back
attached.
Thursday or email you.
Yeah, cool.
But either way, I mean, it's definitely a beneficial course.
Sounds good.
Yeah.
Yeah, it is a useful course.
Yes.
There's not a lot of fat to trim out at this point. So.
I know. I don't want to put off these type of things too long. So, but I'll let you know.
All right.
Appreciate it.
Cool. See you around, Abby.
Yes, thanks.